Okay, we are in Chapter 7. This is still Section 7-1, and this is the recording number 4. The concept is that in order to be scientifically valid, you have to have a certain sample size. And it's common sense, right? If you're talking about the 60,000 students at the Riverside Community College District, if I said I'm going to take a sample size of 10, you'd say, well, that's ridiculous. 10 people cannot possibly represent all of the folks that are at the Riverside Community College District. So you know that 10 is way too little. Well, how about 1,000? Would 1,000 work? Well, you might say, well, yeah, I think it would, but how do you know? Well, there has to be a mathematically sound way of doing it, and here it is. Here's the concept. Okay, so remember that in this formula, I hate to keep bouncing back and forth. It's going to make you crazy, but here's an example of the formula here. This guy right here, this is the margin of error. We talked about that before. So mu is within this range. I'm sorry, not range. It's within this interval. It's x bar plus or minus the margin of error. It's in that interval. Okay? So the margin of error, well, this right here, this z sub alpha over 2, that's the appropriately chosen z value. That's determined ahead of time. You know what that is. There's, for a 95% confidence level, there's a certain z value. For a 99%, there's a certain z value. So once you tell me what you want for the confidence level, that determines what the z value is. The sigma, well, that's kind of determined in the sense that you are making certain assumptions, right? Let's see here. Yeah, for the purposes of this chapter, actually, he says for the purposes of this chapter, I'm not sure that's what he meant. I think what he meant was for the purposes of this section 7-1, because in 7-2, we specifically do not know what sigma is. So I'm not sure if that might be an error, what he says here. All right, so in any event, the formula for the sample size is going to be derived from the margin of error. The only thing that is unknown here, the only thing that can possibly change when we're using this formula right here is the n, okay? So if I want a certain margin of error, that will give me the appropriate level of confidence. That's the only thing that can change, okay? So let's take a look here. The formula for sample size is derived from the margin of error formula. Here's the margin of error, okay? I wish he'd call that ME. That would certainly be more sensible, but this is the margin of error. E stands for error. Margin of error. It's the appropriately chosen z value, is sigma, that we're assuming we know, over the square root of n. Well, do you remember from Math 35? You can solve for any of these variables, right? You just manipulate them. So how about if we manipulate? Why don't we do this? Why don't we multiply both sides by the square root of n? That'll cancel the square root of n over here, and that'll give me this on the right-hand side. It gives me this on the left-hand side. Divide both sides by e. That'll give me this. Now I'll square both sides, and that'll give me this. So n is going to be equal to this. Okay, so the formula for the minimum sample size needed for an interval estimate of the population mean is this. Okay, E is the margin of error. Okay, so you always have to round up because, you're taking samples or experiments or trials or whatever you're doing. You can't have half of a sample or a half of a human being. You can't have half of a toss of a dice or whatever it happens to be that you're doing. So we always round up. Okay, so let's take an example here. I think it'll be more clear. Okay, automobile thefts. Sociologist wants to estimate the average number of automobile thefts in a large city within 2 automobiles. So the within 2 automobiles, that's my margin of error. I want it to be within 2 within 2 in the sense of 2 is the maximum error that I want. Okay. So let me bounce back up here. I'm hoping you guys have your book, because if you don't have your book, it's really hard to follow this, I think. So in any event, using this car theft business, he wants to come up with an estimate for the average. That's my mu, and he wants it to be within 2 car thefts, within 2 events. So that's plus or minus 2. So that's my error here. My margin of error is 2, and my X bar is whatever my X bar is. I'm going to find that out here in a minute. Okay, so he wants to be 99% confident. So that 99% confident is going to dictate what this Z sub alpha over 2 is. It's going to make Z sub alpha over 2 has to be 2.58. Some previous study that was done, the standard deviation was found to be 4.2. So in order to find out what the minimum sample size is to get this interval estimate, what does he have to do? He has to have n has to be at least, now you plug everything in, plug it all in, and you come up with 29.35. So you round it up to 30. So therefore, to be 99% confident that the estimate is within 2 automobiles of the true mean, the true mu, the sociologist needs to sample the thefts for at least 30 days. Okay. All right. So I hope that makes that clear. It's just a way of deciding how big of a sample size do we need in order to make the formulas. Okay. I don't think that this adds anything new here. Okay. The one thing I want to talk about here is, where does this formula come from that we came up with, the ultimate formula being right here. Okay, right here. This is a formula that we've been using. Okay. What I'm going to do on this, you're not responsible for being able to derive this, but as soon as I can, I'm going to do a separate video that talks about this, and I'll write it out, or if I can figure out how to do it, I'll do it on the board and film myself doing it on the board. In any event, that's the end of this tape, or that's the end of this recording. That's section 7-1.